Okay, now we're on to question number 9. Question number 9 said they had to show that 2u squared over u squared minus 1 was equal to 2 plus 2 over u squared minus 1. And then it said hence express 2u squared over u squared minus 1 as partial fractions. So the first point is to notice that the power here and the highest power on the bottom are the same, so we can divide that in. So we can say, we can forget that, we don't have to put an equal sign there, sorry. Right, 2u squared over u squared minus 1. Right, we're going to do 2u squared divided by u squared minus 1, like so. I'm going to say, what do we need to multiply u squared by? We need to multiply it by 2, and that will give us 2u squared minus 2, and when we subtract, that will give us 2u squared minus 2 squared is 0. 0 minus minus 2 gives us plus 2, so that's going to equal 2 plus 2 over u squared minus 1, which is what we were asked to show. Alright. Now we need to just consider this here, and you can see that's a difference of 2 squares. So we're going to have 2 plus 2 over u squared minus 1 is going to equal 2 plus, and then it's going to be a over u minus 1 plus b over u plus 1. And so we can say then 2, we can say here that we're going to equate these two fractions together. So we're going to say that the 2 on the top of the numerator here is equal to, this is a single denominator, a single numerator, we're going to have a times u plus 1 plus b times u minus 1. And in this case, if I take u equal to 1, we're going to get 2 equals, alright, we're going to get u plus 1, that's 1 plus 1 is 2a, and the b's disappear, so we can say that therefore a equals 1. And if we take u equal to minus 1, that'll give us 2 equals, this will disappear, and that will give us minus 2b, so that tells us that b is equal to minus 1. So the whole fraction then is going to be written like this, 2u squared, so we can say therefore 2u squared over u squared minus 1 is going to equal 2 plus 1 over u minus 1 over u plus 1, and that is what we're going to use for our integration later. Alright, okay. I'm going to leave it at that. The next part of the question says, using substitution u equals minus x, show that blah blah blah. So we've got the integral from 4 to 9 of root x over x minus 1 dx. And we're going to use the substitution u is equal to root x. Okay, so if u equals root x, first of all we can say that x must equal u squared. And if I write that as x to the power of a half, then we can say du by dx is going to equal a half x to the minus a half. Actually, we don't need to, yeah, we can do that. Then we can say du must equal a half x to the minus a half a dx. That's going to, if I just write that as 1 over 2x to the half, we can write that as 1 over, remember that's the same as u was equal to x to the half, so it's 1 over 2u. Alright, so we have, so therefore we can say 2u du, so if I just bring that to the upside here, that is equal to dx, and that's our substitution. So we're going to substitute 2u du for dx, and here we've got 1u here, and then that's going to give us u squared minus 1. We need to change the limits. So when x equals 4, u is equal to the root of x, so that equals 2. When x equals 9, u equals 3. So this then is going to be equal to, the new limits are going to be from 2 to 3, and that's going to give us u over u squared minus 1 times 2u du. So that is equal to the integral from 2 to 3 of 2u squared over u squared minus 1 du. And we've already done this here, so we can immediately rewrite that as the integral from 2 to 3 of 2 plus 1 over u minus 1 minus 1 over u plus 1 du. That's easy, they're all logarithms. So that's going to give us 2u plus the natural log of u minus 1 minus the natural log of u plus 1 between the limits of 2 and 3. We can rearrange that just briefly to give us 2u. This is log of u minus 1 divided by u plus 1, so that's going to be plus the natural log of u minus 1 over u plus 1 between 2 and 3. Alright, I'm just going to rub this stuff off the top, if that's alright. I'm just going to simplify that out. So 2u plus the natural log of u plus 1 over u, so u minus 1 over u plus 1 between 2 and 3 equals. First of all, I'm going to have 2 times 3 is 6 plus the natural log of 3 minus 1 is 2 over 3 plus 1 is 4 minus 2u is 4 plus the natural log of u minus 1, that's 1 over u plus 1 is 3. 6 take away 4 is 2, and then we've got log of a half plus log of a half minus log of 1/3. Well, that's divided there, so that's going to be plus the log of a half divided by 1/3 is the same as times by 3 over 1. That's going to give us 2 plus the natural log of 3 over 2. Now we're thinking, okay, how do we get that into the form that they were looking for in the question? They asked you to write it in the form of 2 plus log 3 minus log 2. Well, that's here, isn't it? Because if you've got 2 plus the log of 3 over 2, well, that's just going to be plus log 3. And then log of a over b is the same as log of a minus the log of b. And that's the form that they wanted in the question. Alright, good. So now we're on to the next part of the question. The next part of the question is a little bit more tricky. I'm just going to make sure that I just record the result that we had here. We had the log of that was x to the power of a half over 1 plus x dx. Remember, that was the whole substitution. That was equal to 2 plus log 3 minus log 2. It says we're going to need to use this result or otherwise, but obviously it makes sense to use this result if we can. So we are trying to figure out the integral from 4 to 9 of the log of x minus 1 over root x dx, and I'm just going to rewrite that as the log, the integral from 4 to 9 of log of x minus 1 times x to the minus a half dx, just to help me. Alright, and this is going to be an integration by parts. So remember the integration by parts, I write this u dash v is equal to uv, the integral of u dash v is equal to uv minus the integral of v dash u. It's very easy to remember that way. And we're trying to figure out what our u's and v's are. Now, the point of this question is this second integral here, we're hoping to get into this form here. So we've got an x to the minus a half here, right? That's the thing I want to integrate. So I want to be taking that to be my u dashed, and I'm going to integrate it, and that'll give me something to do with x to the power plus a half. So this thing here is going to appear here, and then we're going to take the derivative. Now we know that the integral of 1 over x is log of x, so the derivative of log of x is going to be 1 over x. So I'm going to use that for this. Alright. So I'll say let u dashed equal x to the minus a half. U then is going to be the integral of that, so add 1 to the power and divide by the new power. So that's going to be 2x to the half, and we've got v is equal to the log of x minus 1, so therefore v dashed is going to equal to 1 over x minus 1. Alright, that's everything I need to put in my integration by parts. We've got uv, so it's going to be u, so it's going to be 2x to the half times v is the log of x minus 1 between the limits of 4 and 9 minus the integral of, now v dashed is 1 over x minus 1, so I'm going to have something over x minus 1, and then I've got u, that's 2x to the half. If I bring the 2 out to the front, I've got 2x to the half dx. Now, that's between the intervals of 4 and 9. Now the point is, we've done that here. This is exactly the same as that. So I can evaluate this between the limits of 9 and 4. I'm going to do that here, and then I'm going to have minus 2, and we've evaluated this already. It gives us 2 plus log 3 minus log 2. So what does this turn out to be? Well, when we do it to 9, x to the power of a half is 3, times by 2 is 6 log of 9 minus 1 is 8. Right, minus 2 times this to the power of a half is 4 log of 3. 6 log 8, 4 log 3 minus that. Right. Now, this log 8 here, remember, log 8 is 2 cubed. I think it's going to be useful for me to combine these together, so I'm going to write that as 6 times 3 log 2 minus 4 log 3 minus 4 minus 2 log 3 plus 2 log 2. That's going to give me 18 log 2 minus 4 log 3 minus 4 minus 2 log 3 plus 2 log 2. So 18 log 2 plus 2 log 2, that's 20 log 2, minus 4 log 3 minus 2 log 3, that's minus 6 log 3 minus 4. And that is actually the form that we were looking for at the end. Alright, and we're done.